of a hassle, but the process is pretty straightforward. Once that's done, fire up IDA, drag and drop your exe file, double check the default settings, and we are good to go. Take a look at this. Here we got a graph of the program showing the instructions and the basic flow. You can see we are currently looking at the WinMain function. Over here, this tab shows the hex view of the exe file, the raw bytes that make up the program. When you write code, you do it in something close to natural language, sort of. Then the compiler translates that into machine code, and what you end up with are these hexadecimal numbers. Those numbers directly correspond to the instructions the CPU executes. This graph view, or the text view, is what we call the disassembly, essentially a human-readable representation of what machine code is. It's the same thing, just visualized in different ways. We've already covered before how a computer stores programs, what instructions are, and how the CPU processes them in detail. If you are curious and want to dig deeper, I'll link those videos in the description. Let's go ahead and run this. Right away, you'll see 4 input boxes where we can enter some values. Let's just try something simple, 1, 2, 3, and 4, and hit the register button. As expected, the registration fails, so where should we start? A great way to kick off analysis is by looking at the strings in the binary. I'll go View, Open Subviews, and Strings. Depending on your setup, not all strings might be visible by default. In that case, just right-click inside the string window, go to Setup, and make sure you check the boxes for the different string styles. There are 3 options that should be ticked for our use case. Let's try running it again, now from IDA. I hit register and the process fails. But notice something. The word failed actually appears on the screen. That's good. It means we found a meaningful string. When reversing binaries, strings can be incredibly helpful. If they are not obfuscated, you'll often find important clues just sitting in plain text. In this case, the word failed is right there. That's great news. Since we saw a failed string in the message box, we can use that as our entry point. I'll double-click the string in the strings list to see where it's placed in memory. Then I'll right-click and choose List Cross References to, which shows us every place in the code where the string is referenced. Looking at the graph view, even if you are not familiar with assembly, you can kind of guess what's going on. There are 2 branches. One leads to failed message, and the other goes to success. It looks like a simple conditional check, like if. Let's step through it. I'll set the run to cursor here and hit the register again. Now I press F8 to step through the instructions. And yes, we are jumping to the failed branch. So this is the decision point where the program determines whether registration fails or succeeds. Now, how can we flip that outcome? There are few ways. We could patch the binary, modify the memory values, or even figure out the real password. But for now, let's just force the program to show the success message. The key instruction here is test. It is just a bitwise AND operation. You might ask, why would anyone need to AND the same 2 values? Well, the test instruction doesn't actually care about the result of the AND itself. It's mainly used to set flags. Specifically, we care about the 0 flag here. So if the result of the test is 0, the 0 flag gets set. Right after that, we see a JZ instruction, jump if 0. So if the value in AL is 0, we jump to the failed branch. If it's anything else, we go to success. This is usually just a more efficient way of checking if something equals 0. Instead of writing an explicit comparison like CMP AL 0, the test instruction does the same job but faster. It sets the flags directly without the extra compare instruction. That's why you will see this pattern a lot in compiled code. It's a common compiler optimization for if value is equal to 0. So what I'll do is change AL from 0 to 1. Anything non-zero will work. AL is the name part of RAX register, the low 8 bits. Now, when I step with F8, we go down the success path and boom, registration successful. That's nice. Of course, this isn't permanent. If we want to make it stick, we can patch the jump instruction, change it to something what will flip the logic. Go to Edit, Patch Program, Assemble. Replace jz with jnz, jump if not 0. That will do it. Then patch and apply it to the input file. That's all it takes. Now, every time we run the program, no matter what we enter, it says success. Congratulations, you just made your first crack. Though, ironically, if you enter the correct password now, it might not trigger the success because the logic flipped. Alright, let's take it a step further and figure out the actual correct password. I'll close everything and start again with the original unmodified file. Back to strings, find failed, check cross references, jump to the graph, and we are back at the decision point. This time, let's use IDA's decompiler. Press F5, and now we can see the pseudo-C code. What the decompiler does, it takes low-level machine code and convert it back into a higher-level programming language, something that's easy for us to read and understand. Here's the condition that determines success or failure. That's our branching point. Now, double-click into this function, as it seems to be the one making decisions. Let's check the return point. Here it determines if registration succeeds. The code is comparing 4 variables, v17, 39, 28, and 43, to expected values. Let's set a breakpoint there, so we can inspect these variables during runtime. I'll input nothing, click register, and the breakpoint didn't trigger. That's weird, so let's take another look. I see it now. There's a WinAPI call earlier in the function get DLG item text, which gets the string from the UI component with specific ID. Such as here, take what is in element 121 and save it to the container named string. If you are not familiar with WinAPI and get dialog item text, we can check the documentation. And I can see it here. If the function succeeds, the return value specifies the number of characters copied to the buffer, not including the terminating null character. So the condition checks if the string's length is less than 4. If so, it exits early, skipping the code we care about. That's why the breakpoint didn't trigger. So let's give it a longer input and try again. I'll enter a longer string 1, 2, 3, 4, 5, 6, 7, 8, 9, 0, 1, 2, 3, 4, 5, 6, hit register, and yes, the breakpoint hits. Now we are in the business. Let's take a look at the variable values. v17 is loaded using argument block, which is basically string from the call up there. The function